continue answering. Thank you, lady. All right, so I have a question, a very interesting problem. It's not hard to trick me into just doing these problems all the way through because I always get like, what's going to happen with this thing? So here's a problem right here, 42. And my suggestion is to rewrite my, see how this is kind of nice. No, Jeff, that goes on the bottom, buddy. There you go, my friend. And then down here, this is cosine over sine plus cosine theta. All right, looks like that's all right.
Isn't tangent sine over cosine, not sine over sine?
Oh yeah, thank you. What the hell am I thinking? That was a nifty trip. All right. I was thinking ahead about what was there. I don't know what that was. And so my suggestion would be to multiply top and bottom of the big fraction by cosine theta sine theta. I mean, that's one thing you could try. Let me see, is there anything else that would do something? I don't know. I mean, this is the first thing I thought to try. Do you guys see why I'm doing that? If I write the pieces like fractions, then it becomes a complex fraction. And how do you kind of simplify a complex fraction? You kill the denominators between the top and the bottom. So in the top, the cosines cancel, and they get sine theta plus sine squared theta. Did this get me anywhere useful? On the bottom, the sine cancels here, but not here. Let me see if I can. So it's going to be cosine squared theta plus cosine squared theta sine theta. So it looks like that didn't really help me out, did it? Maybe it did. Haha, I see something. Anyway, sorry. Let me stop for a minute. This might not be the smartest way to do this, but this is the first thing I thought of. And notice the top, I can take a sine theta out. I'm left with 1 plus sine theta. And on the bottom, I could take a cosine squared out. And I'm left with 1 plus sine theta. That's encouraging. Die. Oh, okay, good. Now, what really sucks about this one, determine whether it's true or false. If false, find an appropriate equivalent expression. So if only what wasn't here, this would be right. So this is false. What is 1 over cosine squared?
Secant.
But there's an extra sine, yeah. So the right answer should be, so the correct equivalent expression should be secant squared times sine. Now, what? See, I just did it. I even told you I could be tricked into doing that, and I did it anyway. Because I was curious. I wanted to see. But again, what do you take away from this? Even though I did that homework problem for you, what do you take away from this? Well, when I have a big ass fraction with some things inside that could be rewritten as fractions, I do that. And I clear those denominators by multiplying top and bottom by the LCD. Right, that's complex rational expression stuff. Will that always work? No. If it didn't work, what would I try next? Well, here's what I would try next. Oh shit, I didn't really necessarily mean to do that. I might try, now on this expression, it looks like this is not going to do any shit, but sometimes, believe it or not, stop. If I multiply by like a conjugate idea, that sometimes goes somewhere. This time it's not going to go anywhere it doesn't seem to be. Okay. I have one other thing I would try. Let me see if you guys, and then I'll just tell you a little bit about one more thing I would try. If this is supposed to equal secant squared, see, that's the problem. I wouldn't try this now that I remember it. I don't know if it's true. I don't know if it's true. So I can't do anything based on what's on the side because I don't even know if it's true. Does that make sense? So if I'm trying to prove an identity, I can look at one side and kind of work the other side knowing that it's supposed to end up being this. So I can use that to my advantage. Here, I don't even know if the identity is true or false. That's always harder because then you can't do that. All right. Anything else from homework?
I have questions about the quiz.
Okay, sure.
Mainly, with all due respect, what the fuck?
Okay.
That was, I felt like really hard, especially that. Okay, I started crying question 1, but like the last one, I didn't know you wanted inverse on that. The one with the triangle?
Yeah, so there are some problems in the homework. One of the most basic things you could do with inverse is find angles knowing the sides, right? I mean, that's, so for example, let me see if I can find some
Yeah, because you were
space.
talking about doing a radian, but then like rounding to the nearest hundredth, and then I was super confused. You lost me there.
All right, and hold on, where'd you guys go? There you are. Okay. So watch this. So if I have a triangle, let's see. If I have a triangle and I know that this is 7 and this is 12, can I figure out what that angle is? It's basically what I was asking. What trig function relates the angle with the sides that I know?
Tangent.
Yes.
Sorry, I didn't realize
So
I was still muted. Yeah, tangent.
tangent theta equals 7/12. Is that cool?
Yes.
So then what's the angle equal? What do I do to both sides to cancel tangent?
Oh, you add the inverse tangent.
Well, you take the inverse tangent. Yeah. So it'd be inverse tangent of 7. And then you just throw that in the old calculator and make sure you're in radian mode and then round that to the 2 decimal places. Yeah.
Okay.
The one about some of you guys had one about voltage and some of you guys had one about profit of a company going up and down. Right. So these both had their own quirks. The voltage, it was 60 cycles per second. So how many seconds per cycle? 1/60th. Right, so then you can figure out, so that's the period. So then you could figure out what K is inside of your, inside, I can't remember, was that the one with, yeah, that was the one with sine, that's right. So in case you had the one with the voltage, the 160 or 170 or whatever the hell it was, that's just the amplitude. So if it was 170, that's the amplitude. And then now you just got to figure out if the period is 1/60th, then what must K have been to make the normal period become 1/60th? Okay, so there wasn't a lot going on with that problem. You just had to realize you've done problems where they tell you it took 10 minutes. So 10 was to go through a cycle. So 10 was the period. So here I just gave it to you cycles per second, which is of course 60 hertz, right? That's what hertz is. So you just had to make that 1/60th of a second for every cycle. The average on that quiz, by the way, was at 80. It was not bad. It's pretty good. I'm not going to say it was like easy, and I'm not going to say it was really hard. Anything else from the quiz? Let me see. Somebody sent me a message saying it was both. That's right. So a couple of the problems were more difficult, and a couple of the problems should not have been very difficult. And you can make corrections. Just to remind everybody, you can make corrections, right? Anything else from the quiz? Okay. All right, let me stop sharing here. Oops, I got to. Whoa, everything went crazy. Oh, shit. That's right. Yeah, got to pay attention, man. All right. Give me a second here. Here we go. All right, let me see. I want to look at one thing here. All right, here we go. For the last question, I was a bit confused. What exactly did you want? That was the one I was just talking. Oh, the last question. That's the one I talked about just a minute ago. The easiest way to do the last question was to do inverse tangent because, let's see. So that's the one you're asking about, right? The one who just said you're a bit confused. Exactly what did you want for those? That was the one with the get the angles of the triangle. Yeah, okay. So again, if I told you I had a triangle, oops, shit. I have a triangle, a right triangle with sides 3, 4, and 5. Can you figure out what the angles are? So let's see, let's call this one theta and we'll call this one alpha. Or you can call them A and B, doesn't matter. So then what's tangent of theta? It would be 3/4. So how can I get the angle? I'll take the inverse tangent. Make sure the calculator is in radians. It'll give me the answer, round it to 2 places, I'm done. Then I can do that angle. Let me see what's happening. Okay, yeah, okay. So again, you guys can make corrections, right? One quiz out of the many that we're taking cannot kill you, right? My intention was not to make a quiz that would make anybody cry. That's never my intention. But you can make corrections, which is always nice. Okay. And overall, it was actually pretty good. Okay. Anything else from the quiz or from homework? All right. So yesterday we had a big identity verification session. We basically focused just on those. I was kind of hoping if people got some more homework done, maybe there'd be some more specific questions. If there are no specific questions, we're just going to get right back into where we left off, which is getting back into 9.5. Or it doesn't even have to be specific. It could be a general question like, hey, can we do some more of that stuff?
Can you do something like 33 on 9.1, please?
All right, let's see. So here's 33. I don't know if I could do something like 33. whenever you see these squared dudes, all right, so here's a good generalization to make. There are definite identities that deal with squared trig functions, right? So then if I see a bunch of squared things, one thing I might look for is I start writing down my identities. So sine squared plus cosine squared is 1. Then I got tangent squared plus 1 is secant squared. And then I've got cotangent squared plus 1 is cosecant squared. Are you guys kind of with me? So am I saying that's the answer for this, to use those? No, I haven't done that problem, so I don't know, but that's what I think. I've got all these identities that deal with these guys squared. And especially in 9-1, that's almost the only identities we know, I think, if I remember correctly. That and like the symmetry identities, right? So I don't have a lot to work with back in 9-1. How could I say this? Do you see how there's 2? Now stay with me. Everybody just stay with me. So every time we do an identity problem, we are all learning more things to look for and maybe more flexibility, what we're able to try to do. To be honest, you're able to try to do any damn thing that's algebraically legal and that is a true identity. You could try it. If those 2 things are true, you could try it, right? Now, on the one hand, that sounds like, my God, I could end up trying 18 billion things for any given problem. Well, no, that's why you temper that with, what do I look for in the problem that will tell me what to try, right? So you're not trying everything for every problem, because then you'll never get anything done. So now knowing this, and especially, do you see how there's a negative secant squared? What is 1 minus secant squared? Or let's say, let me turn that around. What is secant squared minus 1?
Tangent squared.
Tangent squared. So what is 1 minus secant squared? What do I do to both sides to make this become negative and this become positive? I can just multiply both sides by -1, right? Is that, let me stop for a minute. The reason students really dislike identities is because they are not quite as contained as you're used to things being. Knowing that I'm evil, you understand why I love these then. But I want you, what that means then is you try to contain it by realizing, by noticing things about the problem that tells you what to try. So does anybody see why I wanted to write it like this? Because that's kind of like what that piece is. And I've got a 2 here. So do I have a 1? Yeah, I got a freaking 2. So if I rewrite this like 1 plus 1 minus sine squared x minus secant squared x, well, what's 1 minus secant squared x? What's
Negative
1
tangent
minus
squared.
Yeah, negative tangent squared. And what's 1 minus sine squared x?
Cosine
Right? If this
squared.
affects sine squared, I'll get cosine squared. Do you see that? Person who asked me? Who was it? Was it Athena who asked me?
Yeah, I got it. Thank you.
That's okay. And again, I know what to look for. Ooh, Jeff, you teach in the damn class. Of course I know what to look for. But I'm trying, every time I do an example, I try to show you what it is about the problem that made me try what I tried. Right? So I see a bunch of squared stuff. So I'm going to go to my squared stuff identities. Why not? Is it guaranteed to work? No, hell no. But that's a good first step. Why not? Okay.
The idea of breaking the two apart is something that I would not have looked for. So
Yes,
thank you for
thank you.
showing us that.
That is so funky. But each of those ones gets its own use, which that's kind of like another thing. I didn't necessarily, but when I saw that too, I thought it was going to get split because one is featured. So if I put two of these things together, then I get a two showing up. So sometimes when I see a two sitting by itself, that's enough to make me think to try those things, right? Especially if there's some squared stuff running around. All right. And I understand when you're first learning this stuff, you don't know what to look for. Of course you don't. And that's part of the reason why you want to do many of these and you want to watch many of these get done so you know what to look for. Okay. Anything else you guys want to try out? Let's see. Let me clear this away. I think I did that one. Yeah. This one's a little bit freaky. It's got 1, 2, 3 sides. That's neat. I don't know why they, anyway, I see what they did now. I don't know why they did that. Okay. I'm not hearing any other questions. Are you guys doing all right? I'm a little concerned about everybody's mental health, your mental well-being. You guys doing okay out there? I mean, I'm concerned about my own mental health, to be honest. So, okay. Is anybody, how are things going with memorizing all your identities? A little tired from the gym. All right.
For me,
Trying to catch up.
I was just
Go
gonna
ahead.
say, I was just gonna say for me, I didn't really get it at first, but I feel like I'm kind of starting to get it now.
Yeah, see, there's so many things with these identities you're not used to. We just learned Trig. I am aware of that fact. And here we are with all these identities, and we just learned Trig. I understand. But that's why you want your foundation to be pretty strong. And I feel like you all understand the basic foundation of the trig functions being ratios of sides of a triangle, what to do. And I think I told you a while when we first started trig stuff, I said, remember, each trig function is just a ratio of sides of a triangle, but we're going to do so much shit with them. And here we are doing a lot of shit with them. Is this stuff easy? No. Right? And if you came into pre-calculus, a 6-credit course, thinking it would be easy, then you're a little crazy. Well, that's all right. We need some more crazy in the world. And I'm not trying to tell you that you can't do it. I'm not trying to tell you any of that stuff. I'm just saying it's going to be hard. You're not going to get it sometimes. It's going to click eventually. Right? I'm not a parent, but I always thought being a parent must suck because some things you just got to wait for it to click in the kid's head. You can't teach it. They just got to get it. Yeah. So if anybody has kids, you can tell me if I'm right or wrong about that. But I did have kids for a little while. I could relate to that. All right. So I never intend to make you feel like you're hung out to dry on your own, ever. That's why I have some extra office hours. That's why you can always email me with other times if you can't make it to any of my office hours. That's why I make time at the beginning of class for questions. That's why I don't mind if you ask me what the fuck with this test, and I can try to explain what the idea was or whatever. Okay. All right. So
Can I
there's
ask
no
you
other.
here?
Go ahead.
Can you
Say one more
just
time.
skip to 9.5? Can you go back to like 9.2? Because I feel like
Sure.
yesterday's review of 9.1 really helped me understand it, and I kind of feel like we just like skip past 9 really fast.
All right. So here, let me throw this up. Oh, I do have it up there. We went over that triangle, the series of triangles that kind of lived in each other, and we kind of proved these things. And I'm not trying to say that, well, let me see how I can put this together. That obviously wasn't done so that you could do it yourself. I'm not going to ask you to recreate all the steps we took. I'm hoping while I was doing that, you went with me on every step. You can see how each step leads to the next step. And I love it. I'm not saying it's easy, and I'm not saying you should feel like you could do it yourself. I'm just saying it's to me, it's nice to see where these things come from. The reason I was bored by the ones in 9.4 is because they kind of are just playing around with other ones we've already developed. So it's like, let's just add this shit together and see what happens. You know, that's interesting. But these come from analyzing triangles and getting all these sides and getting other sides. And then, you know, it's a little more interesting. Anyway, so we got these, let me see. Did they give them all at one time? No. So there was the you know, we can write this as one line, right? So we only have 2 things to memorize. The big thing in this section isn't really like proving identities. It was just using it with these angles. So was there any trouble with, well, let's see. Let's look at the homework. Blah, 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 blah. There were some verifying identities, but I don't think there's a lot in this section. Stuff like this, I hopefully wasn't too crazy, right? Or do you have any specific questions you want to ask? Or these get a little bit weird sometimes, right? Let's take a look at one of those. I think we sort of did some of these. If I look at number 8, for example, the whole idea, well, and tangent's not one we have to memorize, but before I write all this stuff out, let me see if I can get this real quick. Shit, I can't do it when I've already got stuff written. Bam. Give me a second. I want to pull up that little, oh shit. I want to pull up that little Trig identity sheet we've got. Here we go. Bam. So, all right. So in this problem, I need to know the trig identity that's down here. Let's see. So I'm going to pull this guy over here, I think. Oh, shit. What did I just do? Okay, that works. Now I can't access the other dude. Gummit. Come over here. All right. I think I'm not sharing anymore. Is that right? All right, there we go. Let me try this again. Thank you for your patience. All right, let me see if I can access. There we go. All right, thank God. So, number 8. I have no idea if you guys are having any trouble with these kind of problems. But the idea is I want to write this in the form, let's just use A and B, A plus B, right? I want to write that angle because that's definitely not one that we've got memorized. Pi over 12. If you have the pi over 12s memorized, holy shit. But let me just write down. We're probably going to have it be on mine. Let me write down the general form for this, just so we have it right here. Tangent A plus or minus tangent B all over 1 minus plus tangent A, tangent B. Okay, so now we got that sitting there for us to use. I like it. Let me see if I can see you guys again. There you are. So the whole point to this problem is now to figure out, how do I rewrite negative pi over 12 as a sum or difference of angles I know? So that's what these kind of problems boil down to, is how do I write the angle I don't know in terms of angles I do? So what do I have to play with? Well, I know pi over 6. I know pi over 4. I know pi over 3. I know pi over 2. Are you guys with me? So is there a difference of these two I could take to make negative pi over 12?
Pi over 3 and pi over 4.
Yeah, so if I do the smaller one minus the bigger one, right? And especially notice how the denominators are 1 apart. So when I make like LCD, then the top will be possibly 1 apart if they're different signs. All right, let me stop for a minute. Is anybody not with me on what I'm talking about right now? If you're not, it's okay. Speak up. It's fine. You could even do it anonymously. Anonymously? At least anonymous to everybody else. You can send me a private chat if you just want to say, I have no flipping clue what the shit you were talking about right now, Jeff.
I'm with you. The one question I have is, why wouldn't it be the smaller minus the larger? Or is that?
It is.
Never
it is
mind.
a small.
Yeah, never
Yeah,
mind.
okay.
Never mind.
You're fine, Jason. It's all right, man. I've made that exact same mistake. So now I've got the question is equal to, get out of there. I've rewritten it in terms of angles I know. And now I can use this. So it's tangent of the first guy. And since this is a minus, it's going to be all the lower stuff. Is that, are you guys with me? So it'd be tangent of pi over 4 minus tangent of pi over 3 divided by 1 plus tangent pi over 4 times tangent of pi over 3. All right, I have no idea if that was a problem giving anybody issues. And now you just do it. So tangent of pi over 4 kicks ass, right? That's 1. Tangent of 60, tangent of pi over 3. And again, I don't know how you've memorized things, but tangent is like sine. When sine is bigger, tangent's bigger. 60, sine likes that. So tangent's going to be the bigger one, which is rad 3. At 30 degrees, it would be rad 3 over 3. That's the smaller option. Okay. And now I've got everything for the bottom. This is 1 times rad 3. So that's just rad 3. That's funkadelic. Become a plus. Become a thing. All right. Try. So the big deal with these is really just, how can I combine these to get this number? And once you got that, you use the identity to rewrite in terms of the two angles that you know. Is that all right? Is anybody not okay with that? And again, it's always fine if you're not okay with it, because that's my job, is to figure out how to say something in a different way. All right, I'm just worried about you guys. I don't know if you trust me when I say that. I don't know. Some people just think all teachers are just, I had to go through this shit when I was doing it. Now it's your turn, man. It's not what I'm about. Okay. All right. You leave, let me see. You leave rad on the bottom. Oh, I see. Yeah. You can multiply this. I was going to say, what would you multiply this to rationalize the denominator? Do you guys remember?
1 minus rad 3.
Yeah, 1 minus rad 3. I like it. I wouldn't necessarily, require that to be done because it's enough just to get to this point. But yeah, it's a good point. You really should. So then the top would be 1 minus rad 3 squared. And then the bottom would be 1 minus 3, so -2. And then you can multiply that out, but okay, that's fine. I would probably be okay with this because it's enough to get through this just to get here. Okay, let's do another one. I'm going to clear all this away. Clear. Let's try number 7, maybe. Why not? Let's try number 7. So now the whole point is to try to rewrite 11 pi over 12 as an angle I know plus another angle I know. And again, the parts I've got are pi over 2, pi over 3, pi over 4, pi over 6. One way to do this, by the way, is to take 11 pi over 12. Does everybody understand the goal? Our goal is to take this one angle and try to break it up into 2 that are each ones that I know, right? That's the goal. One way to do this is to try to break 11 up. So for example, 11 is, just to give a dumb example, 4 pi plus 4 pi. Sure, Jeff, 4 pi. Why not? 4 pi plus 7 pi over 12. And that's going to be shit. This will give me pi over 3. Yay, plus 7 pi over 12. Shit. I need both of them something I know. Do you guys understand? This is another way to figure out, instead of trying to start with the building blocks, you could actually start with where you want to end up. So does anyone see a better way to break 11 pi up to make this work? Or is there a way? Maybe it's actually we should be subtracting something. So let's see. So it could be 2 pi plus 9 pi, right? That would be pi over 6 plus 3 pi over 4. That's no good because I don't know that one. Actually, I do know that one. What am I talking about? Pi over 6 plus 3 pi over 4. That's a good one, right? Do you guys see that? You got to talk to me. Does anyone not see that? And again, it's okay if you don't. You can private chat me if you don't want to say it in front of everybody else. Okay, nobody's saying anything. I really feel like I've lost everybody entirely. All right. So you could either start with the building blocks and try to figure out how to combine 2 of them to make what I've got, or you could do this, which is sort of nice because there's only a finite number of possible combinations. So some's got to work. So now I know I can rewrite sine of 11 pi over 12 as sine of pi over 6 plus 3 pi over 4. And what was the equation for sine of a plus b? What does sine of a plus b do? Let me take some of this away. Shit, Jeff, going a little crazy there, buddy. What is, oops, what was here? Boop. What is sine of a plus b?
Sine pi over 6 or a.
Oh, okay. So let me just write the general sine a cosine b, right? Plus sine b cosine a. Sine's a nice guy. So yeah, so now you got sine of pi over 6. I'm with you. Cosine 3 pi. God, Jeff. Plus sine of 3 pi over 4. Jeebus, what language are you writing in? I only thought I knew the one. Cosine of pi over 6. Okay. think that's what it is. My hand knows a different language. All right, let me stop for a minute. So this step is funky, but it's not horrible. There's a finite number of things you have to check to find it. So that's nice. And you've got a couple different ways to do it. Once you get that step figured out, then it's just applying the correct identity. What's sine of pi over 6?
1/2.
1/2, because pi over 6 is closer to the x-axis. Sine don't like it there, so it's tiny. Cosine of 3 pi over 4. What quadrant is that in?
2.
Second quadrant. I like it. Cosine is what sign there? SIGN.
Negative rad 2 over 2.
I like it. Negative. And all the over 4s have rad 2 over 2. I like it for cosine and sine. Plus, that's going to, of course, be positive rad 2 over 2 because y is positive there. And cosine of pi over 6 is going to be the opposite of what this guy was. He's going to be the big guy. So then you get, I'm just going to turn these around, rad 6 over 4 minus rad 2 over 4. And that's pretty funkadelic right there. And of course, at the end, you can always check your work. You can throw this in the calculator and you can throw this in the calculator and make sure they come out to the same decimal, right? You can check your work. All right, all right. All right, so let me clear all this away. So let's see what else. Look at these. These are actually easier than these. This next little step, the first step isn't there. It's already broken up for me. Do you guys see what I'm saying? So you just directly apply directly to the forehead. No, you directly apply the identity. It's already broken up for you. All right. Same kind of thing here. What about number 18? Number 18 is just going backwards, right? Did number 18 come from sine of 2 angles combined or cosine of 2 angles combined?
Sine.
Good, because it's sine, cosine, sine, cosine. And what's going to be the sign in the middle of those 2 angles, SIGN?
Subtraction.
Yes, because sine keeps that the same because it's a nice guy. And then you've got 2x minus 5x. And then one last step on that. What is sine of negative 3x? What happens with that negative? Does it just eat it or does it change?
Negative sine of 3x.
Yeah, cool. All right. Right. So they will give you some that makes you use. So this way, you know, one of these guys, well, these are all freakadelic ones, but you can look up the stuff for these guys. But this is just going backwards using the identity the other way. Let me see. Does anyone have any specific questions? Because otherwise I'm not really sure what to focus on here. I think we did one of these when we first talked about these. I'm pretty sure we did. Okay, all right. Any other things you want to focus on? Anybody? Before we get back into 9.5, anybody? All right. So just get into those sections. Let me know if you have general questions or specific. I get the impression that some of you guys think I'm doing something on purpose or something. No, I need to know what to focus on for you, right? So I've covered everything up to this point, but there could be specific weird little questions in the homework that you're not sure what to do with. There could be like the identity questions. There's other things to look for in the identity questions, but until you try them out and have a question for me, I don't know what to focus on for you. Let me see. No. Nobody's dumb. All right, so somebody just private chatted me something. This is weird shit. Can we all agree on that? It's cool as all hell. Hopefully somebody out there is like, this is kind of cool. I think if only it wasn't so weird, right? But I think you might be able to, or at least you know one guy in the world that thinks some of this shit is cool, and that's me, right? Trig functions just blow my mind because they are so simple. They are just ratios of sides. That's why I said in the beginning, I said, remember that everything we do, all these identities and all these things we've done, trig functions are ratios of sides of a triangle. That's all they are. It's insane. It's kind of nifty. So you have to get used to how to work with them. And as you do the problems, you need to let me know what isn't making sense. You need to let me know. You can show me what you've tried, because sometimes somebody's tried something and they made a mistake somewhere, and that sucks so bad. When you're doing an identity and you're doing it the right way, but you make one mistake and then you think that's the wrong way and you try something else and nothing's working. But all it takes is one negative becoming a plus, or writing cosine instead of cosecant. That's all it takes, man. That's tragic, but those are the kind of mistakes I can live with a little bit more, because they're not conceptual mistakes. You're a human being. You're going to do shit like that, mistakes, right? Those suck, but they're not as bad as not understanding anything. Okay, so I do want to do a little bit out of 9.5. I can look for, I think I have some old handouts. Okay, so what I'm going to do, I think I have some old handouts related to, this is a long time ago, I would have made this, related to some basic things you could look for. I'm pretty sure I've hit most of them. So when you're doing identities, if you have two fractions, you try to get them together, for example, for one thing. If you have fractions inside of fractions, you want to kill those inside fractions. I mean, so it's just some basic things to look for in identities. I can see if I can find that. It just came to mind that I think I put that together one year. Let's try a few of these, and then I'll see if I can find that. And then maybe if I find something, or I can make something for tomorrow's class, and we could focus on handout with some examples of stuff, things to look for. Oh, I don't want to give anything away here. Okay. Do I want to do this up on the board? I sort of want to do this up on the board. What do you guys prefer? Do you prefer the board, or do you prefer this? Is there any preference? Do you like it better when I'm on the whiteboard, or do you like it better when I'm on this thing? Any preference, or you don't care? Or you're all like, you're the teacher, man. We'll just do with whatever the hell you do. Is that what it is? All right. I love you guys. You're all like, I don't know what to tell this guy. Okay, no preference. So I'm going to go to the board because I kind of miss being at the board. Shaboo. Okay. I know. Hold on. Let me get the statistics off of here. let me get this view here. There we go. Doot, doot. Now, I want to do, yeah. Okay. So last time we did some basic, yeah. So we did one, for example, we did something like this. I have no idea why I put the parentheses there. Let's do something a little more interesting. Just to get the basic idea of what you got to look for. Does anyone remember? Can somebody give me like 2 of the most basic answers to this equation? What quadrants would I be in for this to be true?
3 and 4.
Good, because that's where the y pieces are negative, which is what sine goes for. So I'm going to be in 3 and 4. And what angles am I talking about then? What reference angle would they have?
Pi over 6.
Yeah, because you want sine to be small, so you want to be further away from the y-axis. So you want this angle to be smaller. So you want that to be pi over 6. I like it. That's the reference angle. So then my answers are what that angle actually is. So it's 1/6 of a pi past a whole pi. Is that cool? 1/6 of a pi past a whole pi. So 7 pi over 6. And that would be 1/6 of a pi before 2 pi, which is 12 pi over 6. So that would be 11 pi over 6. Are you guys? And I know it was relatively recently that we talked about radians, but it has been, at the same time, it's been a little bit of time. We need to start getting more used to working directly with amounts of pi, right? Okay. So this will be 11 pi over 6. But of course, I'm missing the fact that there are an infinite number of angles that do this, that go here, and the same thing for that one. So what am I going to add here? And I want to say something about what the book does. So I got to go, so to pick all these up, I always have to do a full rotation around to get the next one, and then another full rotation around to get the next one. So I want to add 2 pi k. Now I just realized the book does this, which is kind of dumb because that's supposed to be an integer. But just in case you see that, hopefully you understand. So I might write this, and you'll see this in the book. But if k can be negative, why would I need that there? Does that, you guys kind of with me? Just so you know what to, if you see something. Okay. If you see something, say something. And then here. All right. So that's how I do almost any trig equation. Is I do whatever algebra I need to do, and then I get the angles, and then I have to I got to catch them all. I'm sorry. That came out of my mouth, but I got to catch them all. Okay. So let's do something a little more complicated. Let's try something with a little bit of algebra involved. Oh, let's see. Yeah, okay. Let's see. How's this going to work? Well, let's just see. Let's see if this will work. Now you're going to see why us crazy math people, we sometimes write sine as just s. Because if I do that, especially if I do it like a capital S maybe, we see what to do now a little bit better. What do I do with this?
Factor.
Yeah. So it'll be 2s and s. Let me go ahead and make this sign so it doesn't look like a bunch of 5s running around. 1 and 1, that's easy. And now I need the middle to be negative, so I need the term that picks up the 2 to be negative. Is everybody with me? So that, I don't know if I blowed. Listen to my beautiful grammar. Blew anyone's mind, but all it takes is this guy to be half of this guy, and it's factorable, possibly, if the numbers all match, right? Could you use quadratic formula with trig stuff? Yes. Or are we going to? I don't think so. But you could, actually. Totally. Equals 0. So what does this lead to then? We get 2 sine theta plus 1 equals 0. So I get sine theta equals subtract 1 divided by 2. We get that thing. Isn't that the one we just did? Yeah. So we get those 2 answers that we got. Is everybody with me? We just did those, right? We just did that exact equation. What do I get over here?
Sine of theta equals 1.
And where's sine theta equal 1?
Pi over 2, right?
Yeah, pi over 2. And that's it, right? So then I have to add 2 pi k to that. And just to remind you guys, I mean, so here's the visual. I'm at pi over 2. And every time I get to pi over 2, every time I get here, so I have to go a full rotation around, or I could go several rotations backwards. And again, the book is going to have plus or minus everywhere. Okay. So either way you write it, I'm okay with it because k is supposed to represent integers. So k could be negative. Is that all right with everybody? You guys okay out there? So this is what I mean. A little bit of algebra, and then you end up with that kind of thing, and this kind of thing, where you consider it the same way. You get the base answer, and then you have to add something normally related to the period of the thing. Let me do 2 more examples, I think. Yeah, let me do 2 more examples, and then we'll call it a day. All right, I'm going to assume everybody's got this stuff. Try to do the algebra for this guy. See if anybody notices anything. I'm going to do this 2 different ways. So just do the algebra for this guy. Hopefully everybody's understanding what I mean by that, right? So one thing you could do if you wanted to is to replace this with, like we did earlier, with c or just x. So 2x squared minus 1 equals 1/2, and then solve this for x. But I would hope you would be cool with not doing that, right? So if I add 1, I get 3/2 over there, right? And then I divide by 2. So I get 3/4. What happens on this next step?
Square root both sides.
Plus or minus.
Exactly. Rad 3, I don't know. Rad 4, I do. So this becomes very interesting. So let's consider each of these one at a time. Let me write them out. Because I'm going to get 2 answers here and 2 answers there, right? So what are the base answers for this? I'm going to be in the first and fourth quadrant. Is that cool? Because that's where cosine is positive. And what angles are we talking about? Cosine's bigger, so obviously it's an angle that makes it closer to where it likes it. So a small angle here.
Pi over
So what am I
6.
going to get? Small angle.
Is it pi over 6?
Good, pi over 6. And then this one, technically you're right if you put negative pi over 6, but let's just get the positive part. So again, we saw this earlier. This is going to be 11 pi over 6. I'm just going to start writing it like the book. I don't want you guys to freak out too much about it. Okay. So pretty cool with that by itself. It's very similar to the very first problem we did. And then I look at this guy and it's going to be the same stuff, except now I'm going to be back in the second and third quadrant because that's where cosine's negative. Same reference angle, right? So here I'm going to get 5 pi over 6 for this guy, right? Let's see. And here I'm going to get pi over 6 past that, 7 pi over 6. But, all right. Notice something. I mean, how do I show you? So visually, here's all 4 things, right? Isn't this pi apart? All right. Stay with me. This is so cool if you let it be. If I actually did pi over 6 plus or minus pi k, when I pick up all of these, because what's pi over 6 plus pi? What's pi over 6 plus pi?
7 pi over 6.
7 pi over 6, right? So I can actually, this is what I was trying to get at yesterday very quickly, but I didn't create the right kind of thing. So I can write both of these, I can capture in one sentence, right? So I would probably expect the same thing can happen here. What's 5 pi over 6 plus pi? 5 pi over 6 plus pi.
11 pi over 6.
Yeah, so I can pick up all of those. So I can rewrite those 4 separate things as 2 because these 2 are separated by pi and these 2 are separated by pi. If that doesn't quite make sense yet, we're going to see that a few more times. Now, I told you I was going to do 2 more. This is one. Let's see. What time we got? Okay, we're good. All right. This will be the last problem for today, I promise. I'm gonna leave this here. Just because we're going to do the same problem again, but we're going to notice something about this. Maybe somebody noticed something about that. Did anybody notice something about what I just underlined? Bye.
Doesn't that just equal sine squared x?
No. Thanks for playing. Because of the 2. So if it was that, that would be, would that be anything? Yes, it would be negative sine squared x, but it's 2 of those, right?
How about cosine 2 theta?
Yes. Now, at first glance, you might be like, thanks, Jeff. The shit. But if my problem was this, what would my answers be? Cosine theta equals 1/2. What would my answers be?
Pi over 3.
Yeah, so pi over 3 plus or minus 2 pi k, right? And of course, negative pi over 3, which is 6 pi over 3 minus pi over 3 is 5 pi over 3. All right, let me stop for a minute. Is that cool? Well, I don't have theta though, do I? I don't have theta though. I don't have theta though. I've got 2x, so 2x equals this shit, not theta, because that's not theta, it's 2x. So 2x equals pi over 3 plus or minus 2 pi k. 2x equals 5 pi over 3. Oh, I forgot the, yeah, I don't know. I'm not going to remember. Screw it. 2 pi k. And then how I solve for x. I solve for x. I just divide everything by 2. And you guys, so if I do that, oh shit, I've got everything turned around. Dadgummit. So here I'm going to get x equals pi over 6 plus or minus pi k. Huh. And here I'm going to get x equals 5 pi over 6 plus or minus chop. Pi k, of course, the same answer, of course, because it's the same formula. Which way was easier? This way was easier. Shit, yeah, I didn't have any plus or minus radical shit, right? I don't know if you guys agree, but that's kind of neat. So this is how you handle it. If the inside isn't just x or theta, you actually just forget about this dumb number at first and you solve it like 2x is its own symbol. And then you divide by whatever the hell this is. That seems almost too nice to believe. That's enough. That's plenty. I'll release you guys. So come ready tomorrow. Hopefully I'll find or create whatever that worksheet is. I'm trying to remember. So let me know if you have any questions you need to hang out. Otherwise, I will see you tomorrow.
Thank you.
Anytime. All right, I'm out of here, guys.